Hey everybody, Clark Kent here. This is verifying trig identities. So list all the trig identities that you have. Okay, so far you should have these three right here. Sine squared plus cosine squared equals 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared equals cosecant squared. I remember co goes with co, you guys. Now, can you see from this one right here, I can get these two guys right there. Can you see how I got those two guys? I just subtracted off cosine squared and subtracted off sine squared. Can you see on the second equation, I can get those two guys? Can you see on the third equation, I can get those two guys right there? Okay, so looks like we have 9 different equations that we can manipulate when we get some proving one side equals another side. Okay, so keep those in mind. All those come from off of this one, sine squared plus cosine squared equals 1. All right, okay, so verify that each equation is an identity. All right, with these ones, you guys, for me, it's easier to take the side that's more complicated and try to make the complicated side look like the easy side right here. So that's what my general strategy is at. Okay, here's a Pythagorean identity right here. This is secant squared right here. So I'm going to replace 1 plus tangent squared to be secant squared right there. And then now look at this. One secant down here is going to take one of these two right here off. So I have that right there. And then I'm left with secant over cosecant, and secant is 1 over cosine and cosecant is 1 over sine. So that means this fraction divided by this fraction over here, and I invert and multiply, and I get sine over cosine, which is tangent. That's what you're trying to do. Okay, so you're trying to prove one side equals the other side. Here's another one. Again, I'm going to try and prove the more complicated side. This side looks like it's more complicated to me than this side right here. All right, now what I'm going to do is separate, when I have a numerator with plus signs and minus signs, and I'm going to say this piece over the denominator plus this piece over the denominator, and see what happens there. Okay, now, check it out. The sines cancel on the left and the cosines cancel on the right, and I'm left with 7 over cosine, which is 7 over cosine is the same as 7 secant, and then 5 over sine is the same as 5 cosecant. That's what we're trying to prove right there, so we're done. Okay, try this one right here. All right, one strategy is to change everything to sines and cosines. And so that's what I did on this one, you guys. I made secant 1 over cosine and tangent sine over cosine. And then these guys have common denominators, so I'm going to combine these numerators right here with common denominators right there. So I get 1 minus sine over cosine. See that right there? There's my 1 minus sine. They're both over cosine. All right, now what I'm going to do is FOIL these two top guys out. I'm going to go this top times this one, and then this one times this one. These guys are conjugates of each other. Conjugates of each other always multiply to a difference of squares. And then I have one of those Pythagorean identities from the first part right there. This is cosine squared. So cosine squared over cosine equals cosine, and that's what we're trying to prove. All right, here's another one here. Find a numerical value. So this is basically the same stuff. Find a numerical value of one trig function of x. Okay, so here's not one trig function. I have a couple of trig functions here, and I want to change this and make it one trig function of x. So once I get that, I'll say that trig function equals 2 right there. All right, so I'm going to change this to sine over, actually cotangent is cosine over sine. And then, so I have cosine over cosine still. Here's my cotangent right here. And then what happens is when you have a denominator that's in a numerator, it just slides down with the denominator right there. So it becomes sine cosine right there. Okay, so then now these cosines can cancel, and I'm left with 1 over sine. All right. And then, so cosecant is 1 over sine. So there it is right there. There's my one trig function equals that 2 right there. All right, so that's what they're talking about. Let's do it again with this one here. All right, okay, on this one, you guys, let's see, what did I do on this one? I think, oh, I got common denominators. That's what I did. Between these two guys, I got common denominators. Sometimes you run into dead ends, you guys, and you just got to try something else. And I think I tried something else before, and so anyways, and it didn't work. I ran into a dead end. So my common denominator is sine, and then over here 1 plus cosine. So I multiplied this one by 1, this one by 1, but it was the missing piece right there. Then I'm going to FOIL this out. 1 plus cosine times 1 plus cosine gets me FOIL it out. You get 1 plus 2 cosine x plus cosine squared x. And over here I have plus sine squared x. And look right here, cosine squared plus sine squared is the same as 1. Remember that? Okay, and then I'm going to combine this 1 plus this 1 gets me 2 right there. And then I'm going to GCF a 2 out of those two guys right there. When I GCF a 2 out of those two guys, I'm left with 2 times 1 plus cosine. And then look, those guys cancel right there. Then I'm left with 2 over sine. which is 2 cosecant. And so there it is, my one trig function, 2 cosecant of x equals 4. Pretty cool. All right, we're not going to do that part right there, so I'll just stop right there.